All right, so welcome to the performance meeting for April 19th. Right now we're basically in a freeze for Mimic, so there's not too much activity on VRs at the moment. Mark had suggested that Igor and Radislav, you guys had something to discuss with respect to the Blue Store allocator strategies.
That's not my, I guess. Adam Kupczyk is working on the allocator stuff. I will try to ping him. Maybe he will join in a second.
Okay, thanks. Igor, do you want to describe your work there?
No, actually, we were planning to discuss some approaches to collect statistics for allocator of Adam.
Okay.
I don't have anything to report.
Let's see if we can get Adam then.
Pinged, waiting for a reply.
Thanks. While we're waiting for Adam, does anybody have any other topics they wanted to discuss? All right, there we go. Looks like Adam is here.
Hi guys.
Hello. So Mark had suggested that you and Igor were looking at the free list implementations or allocator implementations. You wanted to have a discussion around those?
Well, actually, we had a brief discussion a couple days ago about the statistics we need for allocator to better understand how allocator works in production, what use patterns we can see there, and etc. etc. I suppose nobody has real understanding what's happening with allocator in production at the moment, and probably we need to bring some additional stats collection or performance counter collection or things like that. I started with just one parameter fragmentation that is mirrored to performance counters. The corresponding PR has been submitted last week. Today I submitted another pull request with locator request and results sizes histogram that can probably help us as well. Also, I know that we are able to check the mem usage of the allocator from mempools. That might be interesting as well, the parameter for allocator. And probably we should consider some other parameters that we might need. Adam, do you have anything to suggest?
Well,
Maybe.
for as much as you said, I can only agree, which my level of confidence that what you're saying is correct is even amplified by my today experience, because I've actually fixed one problem in a stupid allocator, which I fixed that. Now the stupid allocator was able to coalesce neighboring regions together, but in effect I caused an actually more amount of larger chunks, but still it appeared that this schema caused me to not have very large unallocated part, which caused BlueFS to assert. So this actually stresses out that we very much need to get some handle on some snapshot in which sizes our allocator is used in production. I mean, not only sizes, just the histogram, but actual being able to replay both allocations and deallocations, so we can get a hold and devise best strategy to avoid fatal deallocation. Just we will know on which level we have to enter some secure mode just to protect our last very large areas for some emergency. But now we can just guess, and it seems, as for me, not always the guesses are good. So yeah, if that's possible, I would really like to have some ability to store. I mean, maybe on our test cluster or some place, at least one full run, like 1-2 months of working cluster to know what's going on. So that's it.
Well, actually, we can probably retrieve allocators information from RocksDB in existing cluster, since, well, there is a free list class that serializes allocator stuff to RocksDB, and it's preserved there. So if you want to collect something from production stuff, you probably need some snapshot from RocksDB to get
Well,
that.
yeah, that's true. And obviously, if I was only interested in getting a snapshot of what is allocated at the current moment, this is the enough solution. But I was more interested in knowing how it changes with time and how we allocate and deallocate chunks. And I don't know how that information can be recovered. And Igor, if it can, well, I would really just that would make it very easy. Just I will get a hold on existing cluster with BlueStore and extract it, and I will know almost everything I need.
Well, unfortunately, only these recent PRs from my side are intended for that. So I doubt it's possible to collect anything but free list information from existing clusters. And moreover, if we need these stats as soon as possible, it probably should be, well, at least the second pull request should be merged into Mimic. Right now it doesn't land there.
Are these things that could also be backported to on top of Luminous?
Well, it's possible. We can also backport it to Luminous as well.
I'm wondering if a good start might be to install these, like backport these Luminous and install them on Sepia with the long-running cluster that's storing all the Teuthology logs there, and start taking snapshots of those stats. It's certainly not representative of every workload, but it's at least a workload that is a real-world use case.
Yeah, it makes sense.
Definitely, that's better than nothing.
Well, another topic to discuss about this allocator stuff is probably another direction we can go. That is to avoid the need for continuous space. Actually, the only thing that needs it right now is the BlueFS that requires 1 megabyte extents, and actually there is no much need for this continuity. So maybe we can consider another approach and to refactor this BlueFS stuff to be able to work with this sparse extents, and this way we can simplify this allocator stuff and avoid that need for continuous extents. And well, in that case, all that fragmentation questions are not very important, will be not very important for us.
So naively, 1 megabyte, a 1 megabyte chunk doesn't seem like a very large portion of a disk.
Yes, but well, first of all, well, I observed the lack of these continuous extents in some artificial scenarios when this BlueFS partition isn't that long. That's the first comment here, and the second one is that currently we have some hint stuff in allocator that actually run well. So instead of reusing extents from the starting of the volume, it enumerates all the disk, and hence it brings some issues with well, at least it makes the probability for the lack of continuous extents much more possible. So that's actually an open question if it's, well, actually it's possible to get that in production when running for a long time. What's the probability for that? I don't know, but in development setup, I could reproduce that scenario. But maybe in real life that's not that important because the chunk is pretty small and the probability of the lack of this stuff isn't that much. But I believe we should try to avoid any probability of this case in production, because
Mm-hmm.
sooner or later it might fire somewhere.
Sure. And about how full did you have to get the partition in your test case to be able to get it that fragmented?
Say that again, please.
How full did you have to get the partition to get it that fragmented? How much, like, how utilized was the disk in terms of capacity?
Well, I don't have numbers at the moment. There was a pull request about that somewhere. It was pretty small volume, and well, the only thing that I did was just random writes. But since this hint stuff, it reused all the volume space, and eventually it got fragmented. But the volume itself was about 1 gigabyte or maybe 10 gigabyte, no more.
Okay.
Well, I can create a test which will cause this fatal fragmentation for stupid allocator with as little as 1% of full disk. It just requires you to allocate and deallocate. I mean, allocate small and big chunks interchanging, but free the big chunks. And because of the hint mechanism that Igor was telling about, we always try to allocate with the last offset next. So we will just nicely chop our disk into smaller fragments. Then, well, you can arbitrarily select the size of the fragment you want to chop to. So that's, of course, there are probability of anyone making such use of a cluster are small, yet it seems thinkable.
Mm-hmm.
But we can, I agree with Igor that we can avoid this, but by more aggressively reuse existing smaller chunks instead of following the hint so blindly. I mean, for example, maybe we should look a bit before the hint also, or introduce at least some strategy that takes into account both distance from the hint point and the fact that we have to split some other higher order chunk into smaller. Maybe that, but that's of course lacking the actual stats of use for allocator. I'm just imagining things here.
Mm-hmm. So without being too familiar with this code, can you give me more context about the hint? Are we always passing it down from BlueStore, or for most, is it only for some writes, or?
Well, actually, as far as I remember, stupid allocator tracks the hint by itself. Well, there is an option to pass external one from BlueStore, but it's not used. And if it's not passed, then stupid allocator tracks its own hint. And okay. Sage said that's important for rotational drives to provide continuous blocks. So to
try to make the write sequential.
Yeah.
Okay. Yeah, that makes sense.
We thought about, well, maybe alternative approaches to not to provide this hint stuff permanently, but for short periods of time. But still no good enough solution so far. And well, as I said, another approach might be to remove the requirement for continuous blocks for BlueFS at all, and then the fragmentation isn't that important. At least it wouldn't break the store. Rotational stores might work worse, but that's not fatal. And
yeah,
actually,
sure,
I suppose that eventually, due to fragmentation, this hint feature will bring less benefit for the cluster in any case, because we got fragmentation and we are unable to allocate that continuous spaces.
Mm-hmm. I kind of wonder if that sparse approach for BlueFS would be even more costly on the SSD case as well, just for the CPU uses of managing all of the extra sparse extents. It depends on how sparse they are and how many. I guess it seems like kind of the case where we need the stats from to figure out what the allocation patterns are.
Yeah. But just to mention, actually we don't. Well, we use this sparse allocation for raw data, and that's okay for us at the moment. But we require that continuous space for BlueFS. So, I'm not sure that it's that important.
Okay.
But as for me, it's just a matter of refactoring complexity why we are not moving in that direction than performance. So.
Mm-hmm. So I guess
of course I would be much happier if we had fragmentation thought as a problem of performance, not actual availability of the system. And in any case, we would mostly will have just slower down, not any fatal problems. So I agree with Igor that the fix with not requiring continuous chunks for BlueFS is just vital for us now.
Mm-hmm. Yeah, it certainly seems worth prototyping and seeing how much of a difference that makes. Hopefully, I would be able to avoid all the crashes and hopefully not slow things down too much. I mean, if something slows down by like 50% or something, that would be perhaps almost as catastrophic or even worse than crashing, because it ends up slowing down the rest of the cluster as well.
Well, I don't think it will cause much performance impact, since we used to use SSDs for that RocksDB partition, and for them it's not that crucial to maintain the continuity.
Right.
So probably we can get some performance impact, but I don't think it will be that much.
Okay. So this is only for the BlueFS backing RocksDB data, which is hopefully on an SSD.
Yeah.
Okay.
Because BlueStore itself doesn't require this continuous space stuff. It prefers to have that for rotational drives, but it doesn't require it.
Mm-hmm. Yeah, in that case, I think I agree that that removing that requirement for contiguous blocks makes a lot of sense, and likely won't have much of a performance impact.
So maybe that's a way to go.
how tough would it be to modify BlueFS to do that?
Well, I'd say that's not that trivial. Maybe not very difficult, but not just well, it requires some work.
Yeah.
Not a trivial change, I'd say.
I guess the other secondary question would be, if do you think that kind of change would be potentially backportable for existing BlueStore clusters?
Well, I don't know at the moment.
Sure. Something to consider, I guess, when looking at it. So even with a smaller, like, kind of allocation size, are you expecting that there would still be, some kind of minimum size? It would just be like, how small would it be? Or
Well, I think we should use the same settings as we do for BlueStore itself. So that's 4K for SSD drives and 64K for rotational drives by default.
yeah, that seems pretty reasonable. At that point, you can't run into this same kind of out of extents problem without being out of extents that BlueStore would be using anyway, right?
Yep.
Cool. So are there other aspects of the allocator that you guys are worried about besides just fragmentation?
Well, actually, I'm working on another implementation for this allocator based on more on bitmap approach. Well, once ready, we can probably compare the performance between them, but I think there is nothing to discuss at the moment on
Okay.
that topic.
Any other topics you guys want to bring up?
Maybe if I may, performance of our async messenger, especially in the matter of Ceph. There is at the moment awaiting pull request with the op tracker rework. It has been tested on Incerta, also re-verified and profiled directly there. It looks that we have pretty significant contention on the spin lock in OpTracker. However, what is the key part, I believe, is that we got a report that the problem doesn't pop up on a vstart deployed cluster. I was digging in the beginning of this week, and I can find a very substantial difference between the tests and profiling on Incerta that takes place using CBT and a vstart cluster with without disabling Ceph, without applying those two options. It looks that difference that this make is around 1.5 to even 2 times the IOPS we can get from TP-USDTP thread. Pretty significant.
Yeah, that's even more than we've seen in the past, I think.
Could be. However, it could be also that in case of vstart, there is the messenger is a bottleneck which causes less pressure on TPU-SDTP, and thus also less pressure on the spin lock we have in OpTracker that is accessed that synchronizes by default 16 TPU-SDTP plus 3 messenger threads. And I've got a question. Can we assume for performance validation that Ceph should be disabled?
But we can probably assume that if we're not examining if you want to eliminate that piece of it and just focus on the OSD side or the other daemon side, then it makes sense to disable it, yeah. Just like we disable like all the debugging and everything else.
I think if we're doing performance measurements for the impact, though, to justify the complexity of the change, that we need to run it with Ceph, because people basically don't run without Ceph for in real scenarios. And if we have something that's 5% faster with Ceph off and 0% faster with Ceph on, I'm not sure that that's going to be worthwhile to us.
I see. I was googling a bit and found some papers, basically a reference architecture for NVMe testing, and it seems to me that in the attached config there was the Ceph was disabled. Also, we have CBT disabled Ceph. So it's a matter what tools should we use for performance validation? What is the reference point?
Yeah, and so I think Greg has a good point that for real world uses, Ceph is most likely going to be on. But in terms of finding the given bottleneck within the OSD, then it's helpful to test with it off, but it doesn't really tell you whether the changes make sense to an end user. But this perhaps maybe points out that we need to look more closely at trying to optimize Ceph itself to try to reduce that impact.
Could be. I saw that in profiling, I can see a lot of traffic, a lot of CPU usage related in libNSS related to management of the PK11 contexts. Basically, creating them and freeing all the time.
Mm-hmm. And I think Kifu had some proposed patch to try to avoid some of that.
Okay.
Let's see. I'm not sure that he mentioned its performance though. It would be interesting to look closer at that area of the code because I'm not sure it's been much of a focus in terms of optimization. Here's the
Okay, got it.
This is a different one actually. He had a different one that was trying to avoid
PK11 destroy context.
Yeah.
Might makes difference. I will incorporate this commit, those commits, and give them some runs.
Yeah, that'd be interesting. Looks like Casey also says he has some similar work he's been doing around that area. Cleanup, perhaps then performance based.
Also, another question: what is the typical number of messengers working threads in a high-end cluster? I mean, all full SSD configuration, pretty powerful SSDs. At the moment, I'm absolutely sure that by default we have only 3 of them. It might be that even with Ceph enabled, but having plenty of async messenger workers, we could be able to saturate the spin lock in OpenTracker.
Yeah, I'm not sure if we have. I'm not sure I've seen too many people tune that, or if they have. I'm not aware of what kinds of values they're using.
I mean, I think on the really high-end stuff, and I'm not sure people deploy it, but like when Intel's running tests, they're more likely to add OSDs than to add messenger threads. I'm not sure how consistent that is.
Yeah, that's a good point. Running multiple OSDs per NVMe device, so that the entire stack is more parallel.
Do we have such? Is there any link or document describing configurations of those machines? Because adding OSDs per NVMe means that we have with each single OSD we are getting extra 16 TP OSD TP threads.
Mm-hmm.
I think if you just go and look anywhere that Intel has published their like hero run numbers.
Okay, we'll Google for that.
But I don't track them myself. Yeah.
Sure. Thanks for the hint. Anyway, on my laptop, where the initial profiling took place, after I'm at the moment I'm able to replicate no difference from optimizing the spin lock. All I need to do is to just introduce a bottleneck earlier, something like turning the Ceph on.
Mm-hmm.
Then I'm getting much less requests to my OSD TP pool, and I can profiler simply doesn't indicate the spin lock as a hot place anymore.
Yeah, that makes sense. And I think that probably suggests that we should probably focus on optimizing Ceph before optimizing the op tracker. At least for the spin lock case. I think maybe one thing I'm not sure we've tested in a while is the impact of the message signatures compared to just the authentication itself with Ceph. It would be interesting to.
It sounds like another possibility for applying NSS, and NSS context recreation is really painful.
Mm-hmm.
The question now is whether the Kifus pull request addresses also this, or just another PK11 context. Not sure. Well, I will give a test. We'll take a look.
Agreed. Yeah, I think that this is just the generic crypto key context that's probably used for both signature validation and authentication. This is changing the crypto classes, not the Ceph classes.
Cool. I'm merging this pull request into my testing branch and giving it a try.
Great. All right. Anything else? Other topics? For what we discussed. else in here. Thanks everybody. We'll see you next week.
Thank you. See you next week. Bye.
Later on.
Bye.